Hey all you cool cats and kittens, today we're going to be talking about rewriting quadratic equations. So there are three forms of quadratic equations. We have the standard form, which is y equals ax squared plus bx plus c, and that's what our a value, it says whether the quadratic opens up or opens down, and our c value is our y-intercept. That's where the quadratic will cross the y-axis. Our factored form is y equals a times x minus p times x minus q. Our p and our q have four different names. All four of these words mean the same thing. They are roots, x-intercepts, solutions, or zeros. And then we have our vertex form, which is y equals a times x minus h squared plus k. K, that coordinate, is the vertex, which is also called the maximum or minimum, which is also the highest or lowest point on the graph. I recommend you take a screenshot of this or you write down these notes. These are the important things you need to know about quadratic equations. So what I see here is a quadratic equation. It says 10x plus 21 plus x squared. Now these have all of the important parts of a quadratic equation, but it is not in the correct order. We do need our equation to be written in standard form. Standard form says that the term with the highest degree, or the term with the highest exponent, should come first. So this will actually rearrange to be y equals x squared plus 10x plus 21. I'm going to be writing all of the forms up here. So this is our standard form. And now what we're going to be learning today is how to go from standard form to factored form to vertex form to standard form, from vertex form to factored form, from factored to standard, from factored to vertex. We're going to do all of those and move in all the different directions. So I'm going to say the easiest one is probably to go from standard to factored. So in order to do this, we have y equals x squared plus 10x plus 21. And this is just factoring our equation. So this is when we'll do just our regular factoring or our slip and slide or our DB2PS or our factoring by grouping. This guy is just a plain old factoring. So I'm going to find factor pairs that multiply up to 21 and add up to 10. So I know to get to 21, I know 1 times 21 will do it, and I know 3 times 7 will do it, and oh wait, 3 plus 7 is 10. So I would say y equals x plus 3 and x plus 7. And that's it, that's factored form. X plus 3, x plus 7. Now in order to get from factored form to vertex form, you're going to FOIL out your factored form. So x times x is x squared, x times 7 is 7x, 3 times x is 3x, and 3 times 7 is 21. So we end up with y equals x squared plus 10x plus 21. Oh look, we are back at our standard form. Now to get from standard form to vertex form, we are going to do our process completing the square. So completing the square is that activity where you leave space. You draw on your square. Right, here's my square. It's not very pretty, but that's okay. And you're going to put these pieces into your square. So I have my x squared is represented. My 10x goes in both of these boxes, so I end up with 5x and 5x. That means that across the top, we would have x plus 5 and x plus 5, and 5 times 5 is 25. So now I'm going to move over here and leave my space. Y equals x squared plus 10x, leave space, plus 21. In this space, I'm going to put 25 because I completed my square. So plus 25. If I add 25, I also have to subtract 25 because I need my equation to stay equivalent. So I end up with y equals, this whole thing, this x squared plus 10x plus 25 is all equivalent to x plus 5 squared. X plus 5 squared. And what I have left is negative 25 plus 21, which is negative 4. And this is our vertex form. Y equals x plus 5 squared minus 4. And now what I'm going to do is take my vertex form and now I'm going to show you how to get from vertex form to factored form. So what I need to do here, another word for factors or our factored form is our zeros. And it's called zeros because that's when we plug in a 0 for y. And what we have going on here is a literal equation where we are solving for x. We want to get x by itself. So the first thing I want to do is get the part with the x by itself. That's this x plus 5 squared. In order to do that, I'm going to add 4 to both sides. I end up with 4 equals x plus 5 squared. Now if I want x by itself, my next step is to get rid of this exponent. To do that, I need to take the square root of both sides. The square root of 4 is positive or negative 2 because negative 2 times negative 2 will still give you a positive 4. So in this case, I have positive or negative 2 equals, and the square root of x plus 5 squared is just x plus 5. Now if I want this x by itself, I'm going to subtract 5 from both sides. So now I have two equations. I have x equals positive 2 minus 5, and I have x equals negative 2 minus 5. Well, positive 2 minus 5 is negative 3, and negative 2 minus 5 is negative 7. So these are my roots, or my x-intercepts, or my solutions, or my zeros. But notice in the equation, our equation says x minus p. So if I were to put these roots back into my factored form, I'm going to use the opposite of what appears here. So this ends up being y equals x plus 3, because we're doing an opposite, times x plus 7. And now we're back at our factored form. So as you can see, we are able to move from our standard form to our factored form, from our factored form to our vertex form by going through our standard form, and our vertex form to our factored form by rearranging the equation.